Hi, in this video, we're going to introduce the transport layers, specifically, well, the two protocols involved, TCP and UDP. So first of all, I just want to mention TCP IP is a very complicated suite of protocols, a lot to it, especially with TCP. So a couple of books I just want to recommend. The long-term Bible of TCP IP was TCP IP Illustrated, originally by Richard Stevens. He passed away a number of years ago, and it was such a popular book that Kevin Fall wrote a second edition with using Richard Stevens' original book. I also want to mention the TCP IP guide. This is an excellent book and very thick, but very well written and has everything in it. It's also available at a reasonable price, and you can go to the tcpipguide.com website to get more information on purchasing the book. But it's also available online for free. So all the information in the book is also available online for free. I'm a book person. I like books, and I think this is an excellent one to have. All right, let's get started. The transport layer. So the transport layer is responsible for end-to-end communications over a network. Okay? There's two protocols involved. There's Transmission Control Protocol, TCP, which, by the way, that PDU, so the header and its data is known as a segment. And there's also User Datagram Protocol, UDP. And the PDU for that is known as a datagram, or can also be called a segment. In the upcoming videos, we're going to be learning a lot more about both of these protocols. So this is just an overview. So first of all, we have the network layer, IP, and data link layers, which are best effort delivery systems. Okay, they don't have any guarantee as far as making sure the data gets there reliably, or any of that. They're just best effort delivery systems. It's the transport layer that's responsible for end-to-end communications over the network. And we're going to see specifically as far as any reliability and what we also call flow control, that's specifically a part of TCP. We'll see that TCP and UDP, although both responsible for end-to-end communications over the network, they have very different requirements. Okay? So the transport layer, I've mentioned, provides end device to end device communication services for the applications. Okay? This is going to make more sense as you go through these videos. Provide services such as segmentation, and we have a video later on this, but taking the original stream of information, the bulk of data that needs to be transferred, and dividing it up into segments. So we have a video on that coming up later. Also, connection-oriented communications for reliability and flow control, as we'll see in a moment, that's specifically TCP. And connectionless communications for time-sensitive or transaction-type messaging. We're going to see that specifically for UDP. Okay, so both TCP and UDP provide segmentation, taking the original data stream up and breaking it up into chunks. They also both provide some sort of data integrity using a checksum. They also use something called port numbers, indicating which application the data actually applies to. It says applies for, applies is, a little typo there, but that's okay, what it's applied to. All right, and we're going to learn a lot more about port numbers in a later video. But TCP ensures that the data is sent reliably, ordered, and if it's out of order, it's reordered, and there are no duplicates. Okay. TCP, as you can see between the two headers, is a much more complex protocol. There's a lot of things in the TCP header that are not part of the UDP header. Okay, so UDP, there's no guarantee of delivery, doesn't care about reordering the packets, the segments, doesn't care about duplicates. Okay, so much simpler header. All right, let's look at TCP, at least do an overview of that right now. So TCP defines how to establish and maintain a network conversation between two end systems in order that the application programs can exchange data. And we're going to see how this is done a lot more in the upcoming videos. But some of the things it ensures is reliability, ensures that all the information is transmitted reliably, including any retransmission that needs to occur because of missing segments, dropped packets. Make sure it's error-free. So if there's any problems, missing packets, packets that contain error or whatever, they're retransmitted. And that order delivery, okay? If any packets arrive out of order, okay, I say packets, the segments are of course inside those, encapsulated in those packets, the TCP can reorder those. There's something called flow control that makes sure that the data is sent at the most efficient rate that the receiver can process. And congestion control, various mechanisms and algorithms to achieve a high flow rate of data and to avoid congestion. So we're going to be looking at reliability, flow control, and a little bit on congestion control throughout these series of videos. Okay, so TCP is used whenever data needs the services of reliability, flow control, and/or congestion control, such as file transfers, email, remote login, web. Most HTTP and HTTP traffic uses TCP. And this actually includes most video on demand services like Netflix. We think Netflix and video on demand, wait a minute, don't they just push the data out there? Why do we need any kind of reliability, flow control, or any of that? Well, it actually has a lot to do taking advantage of TCP's bandwidth probing and congestion control. We'll go into a lot of details here, but Netflix and these video on demand services are actually run over TCP, not UDP. Okay, so TCP is a connection-oriented protocol. Okay, requires both the sender and receiver to actually establish a connection before any data can be sent or received. Okay, this is known as the TCP three-way handshake. So this has to take place before any data is actually sent or received. It's basically one side saying, I would like to establish a connection to use your services, usually done by the client. The server acknowledges this, saying, yeah, I acknowledge your request and I'm okay with this. I'm actually going to reserve certain resources or allocate certain resources for you to do this. And the client then says, okay, I acknowledge that you're okay with this, so let's go ahead and do it. We'll talk a lot more about this in TCP's three-way handshake. Okay, it's initiated by the client requesting services of the server, okay? And it remains established. This connection remains in effect until one or the other end either terminates the connection or it gets timed out by the application. Okay, UDP. Let's take a look at UDP. UDP just provides the basic functions for delivering data between the appropriate applications with no guarantee of delivery, ordering, or duplicate protection. So UDP is what we call connectionless. There's no three-way handshake. One end just sends data and the other side says, oh, do I need to respond? If so, I'll send a response. It's known as a best effort delivery protocol. So what is it appropriate for? It's appropriate for time-sensitive applications like voice over IP, okay, where we don't really care about we don't care about bandwidth probing or congestion control because basically we just got to get the data there sent as quickly as possible. Okay, applications that when the application will handle any transport services that are usually handled by TCP, such as TFTP, Trivial File Transfer Protocol, So with TFTP, for example, data is transferred from the client to the server, or let's say from the server to the client, from one end to the other end. And as far as all the data getting there reliably and everything gets there, UDP doesn't care. The application TFTP actually handles that. And if there's any problems, we'll then we'll let the user know that the data has to be resent, usually the entire file. Okay, also transaction type protocols that require minimal communications. So if it's some sort of communications like DNS or DHCP, where the client just says, I need something, and the server says, here you go, then UDP works great. What happens if the client doesn't get a response? Just asks again, just like asking for coffee. I would like a cup of coffee. Oh, maybe you didn't hear me. I would like a cup of coffee. Oh, here you go. All right. So UDP provides just the basic functions for delivering data segments. Like I said, no guarantee of delivery, ordering, or duplicate protection. We mentioned that's appropriate for time-sensitive applications like voice over IP or Skype. By the way, Skype can also use TCP. File transfers without any transport layer guarantees. The application, if it wants that, it will have to handle it. Transaction type protocols, where minimum number of query and responses. Like, I need this, here you go. Okay, mentioned DHCP and DNS. All right, we have a lot more coming on both these protocols, especially TCP, so stay tuned.